Okay, so we're continuing this question of how does the value of c affect the graph of f of x equals ax squared plus c. How is the c affecting it? We've looked at how we can compare it to the parent function. So today we're going to do something a little bit different of this video. So we have new instructions. It's no longer a comparison. We're going to first of all describe. So that's going to change what we're doing, and also it's no longer with the parent function for the first time. Remember, every other time we've done this, we've looked at the parent function and we've compared it to the parent function. This is the parent function. It's the one we use every time. This is the the formula for it. This is the table we'd fill in. This is the graph, and we just kind of looked and saw how the graph would either be translated or how it would either stretch if it's a whole number or shrink if it's a fraction away from the parent function. That's all we've done. But now we have a new set of instructions, and that new set of instructions is to describe the transformation from the graph f to the graph g. So how is it transforming? But it's not giving us that parent function. It's not giving us the f of x equals x squared anymore. So let's dive into that and see how it works. Okay, so the first step is describe the transformation from the graph of f to the graph of g. So first we're just going to describe it. So if we look at this, it says f of x equals a negative 0.5x squared plus 2. But and it says g of x is just that f of x. It's what this one was, minus 7. So it's the same thing as g of x is the same thing as f of x, except the one difference is that you're subtracting 7 from it. Another way to look at it would be to take this equation, these two equations, g of x equals f of x minus 7, and the f of x, which is a negative 0.5x squared plus 2, and just put the f of x in the place of the f of x up here. You're substituting it in. And so really, g of x is the same thing as that 0.5x squared plus 2, but you're just doing an additional minus 7. See how it's the f of x? See how it's the f of x? It's the same thing. Okay, so that's all. Sorry, there's some noise outside my classroom. So that's all we're doing is making that transformation. We're describing it. Okay, so the answer is very simple. The answer is very easy on this. Because it's of this format of y equals f of x plus k, this is the general formula you would use. You're taking that original f of x and you're just adding a k to it. You're adding, in this case, it's a negative 7. So when it's in this format, all you're doing is paying attention to this k, which is a negative 7, and you're doing whatever it says. In this case, whatever the f of x is, you're going to go down 7. 7. Now, we don't know what the f of x is yet. We haven't graphed it, but I'm just showing you. You're just going to count down 7. And so you can answer that first question without really doing much math. Just look at it. You see it's a negative 7 here. You see the k is a negative 7 when it's in that format. So when it's in this format of y equals f of x plus k, the k is a negative 7. So it was how would you answer A? You would say it's a translation. So that's all it is. It's a translation. 7, negative 7 units down. So that's it. So I'll write it. So graph of G is a vertical translation (7 units down) of graph f are you can put of x. So it's the graph is of g. What's with the g? Is a vertical translation 7 units down of x. Sorry about the noise outside, guys. I'm filming this during lunch today, so it's even distracting me a little bit. So then find, the next step is then graph f and g in the same coordinate plane. So all we're going to do now is graph it. So do you notice this was a -7 to review? And the answer is that it's a vertical translation down 7 units. So whatever this is how you would describe the change in the graphs. So then graph f and g in the same coordinate plane. This is really easy to do because we've done these steps several times. What is the first step in graphing? That's right. You make a table. First step is you make a table, you plot it, you draw a curve smoothly through the points. We've done this all throughout, so we just need to graph these. When I make my table, though, it's going to be interesting. It's not going to be the same way I made the tables earlier. Because earlier, I was only concerned about one equation, and now I'm concerned about both the g of x and the f of x. Okay, so when I make my table this time, I'm going to put an input, but I'm going to get two outputs, one for each equation. Okay. So what do I want to input in? I'll do it like a -4, -2, 0, 2, and 4. Okay, those are my inputs. So I need to see what I would get for my f of x. And then what would I get for this newly g of x? Which you remember has the f of x contained in it. Okay, so what would I get for the f of x? We can work it out. I should get a separate sheet of paper probably. Didn't take up too much room. Do I have a separate sheet here? Yes, I do. Okay, so let's plug it in. So everywhere I would see an x, I'll substitute in a -4. That's all we're doing. So we have g of -4 equals f of x. Oh, sorry, the f of x equation. The f of x equation is right here. So we need to figure out what it is with the f of x first. Let's do that first. So we have f of -4 equals a negative, and 0.5, we need to convert that to a fraction so we can do this. So 0.5 is the same thing as 5/10, which would equal 1/2. 0.5 is the same thing as 1/2 x squared plus 2. And the first number we're going to substitute in is a -4. So instead of an x, we'll substitute in a -4. So we just do the order of operations. A -4 and a -4. Well, a -4 times a -4 is a positive 16. Half of positive 16 would be an 8, -8. But then you add 2 to it. So if you were to substitute in a -4, you would end up with a -6. We do the same thing. After a -4, we try the next number, which is a -2. If you substitute a -2, what would we get? Well, let's do it quickly. We won't write it all down. A negative times a negative is a positive 4. Half of 4 would be half of 4 would be 2. So you'd have a -2 plus 2. You'd end up with a 0. So I'm filming. Just let them know I'm filming. Thanks. Sorry, guys. Sorry for all the distractions. I'm getting a lot of distractions myself. A lot of students wanting to come in. We're popular. What can we say? If we substitute in a 0, what would we get? again, it's just going to be 0 squared is 0, 0 times 0 is 0, you have a positive 2, it'll be plus 2. And then it should be symmetric from here, so 0 and negative 6. Okay, so we did the f of x, but now we need to do the g of x. And the g of x is this f of x that we just did, right? But you're taking away 7. So all you really have to do for the g of x is take away 7, right? What's a negative 6 and a negative 7 would be a negative 13. A 0 plus a negative 7 would be a negative 7. A 2 and a negative 7 would be a negative 5. A 0 and a negative 7 would be a negative 7, and a 6 and a negative 7 would be a negative 13. See that we've done what we've always done. It's just that we added this extra g of x, and we took away 7 from it. Okay, so now when we graph these two graphs, let's go ahead and do that. So what's the first coordinates we're concerned with? If x is a negative 4, f of x would be a negative 6. So let me scoot this over. Here we go. If x is a negative 4, 1, 2, 3, 4. Negative 6, 1, 2, 3, 4, 5, 6. If x is a negative 2, 1, 2, it's 0. If x is 0, it's 2. If x is a 2, it's a 0. And if x is a 4, it's a negative. The f of x is a negative 6. Okay, you can kind of see how this parabola is going. Good. Now, how does the new graph look? Well, if x is a negative 4, we go back to the x. The g of x is a negative 13. So negative 4 is the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It would be somewhere down here. If x was a negative 2, it would go down to a negative 7. X is a negative 2, it would be a negative 7. 1, 2, 3, 4, 5, 6, 7. Here. Oops, the other one I didn't do 4, did I? Screw it over. To 4. Okay, so if x is a 0, the g of x would be a negative 5. X is 0, negative 5. 1, 2, 3. Okay, and it's going to be symmetric, right? So if I do 2, it should line up with this 2. If I do a 4, it should line up over here. Okay, so now we just connect the parabola. Okay, so all you're doing is graphing both, but just adding a negative 7 to the second one. It's pretty easy to graph it. Okay, what is the last step in all this? We've already done a lot. Let me find the instructions. Oh, here we go. It says, write the equations that represent g in terms of x. That's the easiest part of all this, because all you're doing is taking that f of x and the g of x, and you're writing them in terms of each other. Oh, there's the equation. Here it is. So if I were to take this f of x and substitute it in here, I would basically have g of x equals whatever the f of x is, which is a 0.5 x squared, plus 2. That takes care of the f of x, but now we just need to take away 7. So the only math you can do, the only calculations you can do is 2 take away 7 is a negative 5. So g of x equals 0.5 x squared minus 5. So that would be the answer to the third part of this question. Anyway, I hope that was helpful in getting that done.